I got a few questions about one of the homework questions from the normal distributions section, and I figured it would just be easier to show you all visually what's going on with it. It uses well, I guess before I explain it, let me show the problem. It's number 29 from the homework. You might be familiar with it already, and it looks fairly similar to one of the problems we did in class. But instead of them wanting us to determine really the boundaries for the grades, they want us to determine the percentages. And it seems a little bit odd. They still give us the same values as before. The average is in this case 80, standard deviation is 5. So it starts off the same, and they still give us a collection of values here, ultimately z-scores that correspond to different grades. But then they want us to figure out these percentages. And so what we have to do here, we have to utilize the 68, 95, 99.7 rule, which explains how data is clumped together in different intervals. So this is also indicated by the fact that this is normally distributed. So when we have a normal distribution, we can use the 68, 95, 99.7 rule to help us determine what percentages belong in which intervals, and these intervals being characterized by increments of the standard deviation. Again, it sounds a little bit more technical when I use the verbiage like that. So let me just go ahead and show you all by starting off with the first part. What percent end up with an A? Okay, so A obviously is right here. So something about Z is greater than 2. So we need to figure out the percentage for when the Z-score is greater than 2. So what I recommend to do is utilize this chart that we have in the course notes, because this gives us a very elaborate explanation of how the percentages are broken up. And so I'll write that again here. Z is greater than 2. That's for the A grade that they want us to know about. Now, one of the unfortunate things about this graph, it's a very well-detailed graph, but the nomenclature that they use here on the x-axis, well, it's a bunch of Greek letters. People don't really like those too much. So let's look at it a slightly different way. So I'm going to put a 0 here because that represents the center. And the 0 in particular means your 0 standard deviations from the mean. And then as you go to the right, you get 1, 2, and 3 standard deviations away from the mean. And I'm going to put -1, -2, -3, which represents z-scores. So that's ultimately, remember, z-scores and standard deviation are pretty much the same thing. The z-score is a more concise explanation of the standard deviation. So ultimately, we have a list of z-scores. Now, in our problem, they're concerned with us figuring out when z is greater than 2. Okay, so our first question, where do we start at on this graph? So in other words, what about when z is 2? That gives us a starting point. So when z is 2, I'm going to circle that in blue here. So that's going to be where we start. But this wants us to look at the region whenever z is greater than 2. So when z is greater than 2, you might remember this from the car problem that we did. So that's these the two subsequent regions to the right here. That's that region is characterized, or that's representing when the z-score is greater than 2. So the only thing we have to do, those shaded regions have 2 percentages involved with them. The 2.35, because we shaded that part, and the 0.15, because we shaded that part as well. And guess what our answer is? We need a percentage of that region that corresponds to that region. So the 2.35 plus the 0.15, 0, carry the 1, 5, 2. So it's 2.5. That's it. That's the answer for the first one. That is the percentage of values that would be in the A range. And so we figured that out by using this chart, or in other words, using the 68, 95, 99.7 rule. So we can go ahead and put 2.5 for the first one. 2.5 for the first one. Right, so now the question is, well, what about the next part? What percentage of students, so they don't really care about a B grade as much, end up with a C in the class? So we're going to skip B and look at a C grade, which we can all see this corresponds to a Z-score between -1 and +1. So we're going to go back to our chart over here. Anything, let's change our attention to -1 to 1. And so this gives us an idea, just like we're going to do before, or just like we did before. Start with a clean slate here. And we'll go ahead and figure out the region we need to look at. So this is corresponding to a z-score of -1 and a z-score of +1. So we're going to identify both of those. A z-score of -1 is over here, and a z-score of +1 right here. And it seems like the variable z is in between those two. So exactly, it's in between. We are looking at the region in between -1 and +1. And I'm not going to shade in those percentages because we need those. But it's this region that we're visualizing. And the sum of those regions, well, it looks like we got 34 and another 34. So 34 plus 34, and guess what? That's 68. Or you may have also seen that because -1 and +1 represent one standard deviation from the mean, which gives you 68%. So that's two different ways you could look at it. But in any case, we get 68% nonetheless. So let's go ahead and put that one for the next part, 68. And finally, it asks about what percent of students will end up with a D or an F in the instructor's class. So this is asking us to analyze these last two here. So I'd rather not do the whole problem, but I do want to give a nice hint to get you going now that you see the idea. So -2, -1, and z is less than -2. We'll go ahead and just write them all over here. So for the D grade, that was -2, -1, and then for the F grade, that's just z is less than -2. Now, again, I'm not going to finish this problem. I want you all to kind of think about it now that you have the right tools, but this is ultimately referring to two shaded regions, the D region and the F region. And so these z-scores you need to determine are based off of, well, -2, which is right here. There is also -1, which is right here. And then something about z being in between them. And then there's also a region corresponding to F. Once you find those regions, plural, so that's another hint, you add all those together, and that would be your final percentage. So hopefully this gives you a good idea about how to go about this problem. And I'll go ahead and wrap it up there. Have a good day.